Right, so we are officially live. Welcome on in, everyone. I'm Robert, the AP Math Guy, and tonight we're going to be talking about related rates. So, tonight we're going over part one of related rates. So, I have 10 problems, 5 of which we're going to do tonight, and 5 of which we're going to do tomorrow. So, I'm just going to cut these out now so that way we can get them ready to go. So hopefully everyone is having a good Wednesday night. I know I am. But then again, every day is a good day. So yeah, I apologize for the little bit of background noise. I'm just cutting some problems that we're going to do tonight. So, if you are here, be sure to hit those hearts. There we go. But yeah, so welcome on in, everyone. Hey, Desmos King, how's it going? Did I just start? I did indeed. I just started about 2 minutes ago, but we haven't started the math yet. Awesome. So yeah, how is your Wednesday going, Desmos King? Did I ever create a channel over there? Yeah, I do. I do have one over there. In fact, here it is. And I've had that channel now for a little while, but it's been a minute since I posted anything on there. You live an interesting life? That's awesome. Well, hopefully today was very interesting. As I said, I'm just cutting some problems so that way we can work on them. And I have 10 of them prepared, but I want to do I want to split them up 5 and 5. Do I know about stocks and markets? A little bit, but not. I have to admit, not as much as I'd like. What country am I in? I'm in the U.S. That's really cool, Desmos King. That's really cool. I basically traded them and make 8K the last 2 days. And I agree. Anything is possible. And that's awesome. Congratulations. You're welcome. I did. It's not just my wins and losses in here that are important. It's yours as well. It's all of yours. So now I have my cut problems for tonight cut. There's some applications. But yeah, so if you are joining in that's fair. But yeah, um, I don't recall. Um, and if I have all, what they were losses because of course they were. But I am not. I am not the I'm not the stock. I'm not the stocks guy. Um, if you want if anyone if you need financial like stock market advice, I'm not the person to give it to you. But yeah, I apologize if the camera is there. You go. I just had to adjust the camera. Yeah, thank you all for joining in. I mean, you strike me as a quant guy. They love math. Well, okay, like a quantitative analyst kind of thing. Thank you all for the likes. Fair enough. But yeah, so I'm gonna go ahead and I'm gonna go. I just realized I forgot to wave at you all. My apologies. I want to say hi. I'm gonna so in case I couldn't click on you to say hi to you. I'm gonna wave to you now. Hi everyone. So tonight, let's talk about related rates. So the other day, actually, before we get there, I do have one thing I do have to mention before we get started. So normally I go live every night at 11:30. However, on Friday I have to get up early on Saturday morning because I have a trip about I think 3 hours north of where I am. So because I have to get up so early, I'm gonna do the live earlier in the day. Right now I'm trying to find the time. I think I'm going to go live at like 6 o'clock on Friday afternoon. So I'll let you all know that I'll remind you all tomorrow about that as well. But I'm going to be going live earlier on Friday, so that way I can not drive half tired on Saturday. All right, so let's talk about related rates. So so on Monday we did what's called implicit differentiation. And why is that important? It's important because it's going to help us solve real life problems revolving around derivatives and how things change over time or how things change instantaneously. So let's go ahead and start with our first problem of the night. And let me know if you're able to read that. Do I need to zoom in or out, or can you read that okay? It's good? Okay. Awesome. So, a rock is dropped into a calm pond, causing ripples in the form of concentric circles. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. When the radius is 4 feet, at what rate is the total area of disturbed water increasing? So, the first thing that I'm going to do to solve these related rates problems is I want to literally draw what's going on. So I'm going to give everyone a fair warning about this. I can't draw. I'm lucky if I can draw a stick figure correctly. So I apologize tonight for the drawings that you're going to see. They're awful, and And that's because I can't draw to save my life. So, with that, let's go ahead and attempt to draw these concentric circles. So, we're going to look at the pond from up above. So I have a little circle here, a little bigger circle here, even bigger circle here. Now we'll draw one more just to be... And we'll say the rock has dropped already. So, the radius of this outer ripple, which is this circle out here, is increasing at the rate of 1 foot per second. So, it's really important for us to look at problems and see what they're giving us. So, let's read this. A rock is dropped into a calm pond, causing ripples in the form of concentric circles. So we know that all the shapes are going to be circles. The radius of the outer ripple is increasing at a constant rate of 1 foot per second. So what is radius? Remember that radius is the distance between the center of a circle and any edge. And we know, what do we know? We know that the radius is increasing at a constant rate of 1 foot per second. So our radius is changing over time at a rate of 1 foot per second. So I'm going to write that as dr dt. And because we're increasing, we're going to be positive 1. (16 feet squared, right? Because every circle inside the outermost ring is already disturbed. Well, right. Well, we're only we only care about this outer ring, outer ripple. So, when the radius is 4 feet, at what rate is the total area of disturbed water increasing? So we know that our radius is 4 feet. So my radius is going to equal 4. And we want to know at what rate the total area of the total area of disturbed water increasing. So our want is to figure out how the area is changing over time. So that is dA dt. So that is our want. So I'll put a question mark to symbolize that's what our want is. The rate, I read the question wrong. Okay, no problem. Have I done circle theory? I have to admit I haven't, only because I don't know what that is. So now we need our next step. So we've drawn we've drawn our situation, and we've listed everything we know. The next question is, now we need to relate the radius to the area. So how do I relate radius to area of a circle? What do you think? Well, area is pi right squared. Do you mean pi r squared? Perfect. Yeah. So area of a circle is equal to pi r squared. Very good, okay. Very good. So now I've related area to my radius, or should I say, I've related my radius to area. So now that I have that formula, now I have everything I need to find the answer to this question. So what I'm going to do is I want to find dA dt. So in order to do that, I need to take the derivative of the left side. However, when I take the derivative of the left, I also have to take the derivative of the right. So the derivative of A is just going to be dA dt, because, right, tonight, we're going to be deriving with respect to time. So we're going to have d variable dt anytime we take the derivative, unless it's in time itself. But that's a whole different course for another. That's a whole different type of problem for a different day. So, what is the derivative of pi r squared? What is the derivative of pi r squared? Well, let's take a look at our rules. That's okay, Twinkle. It's okay not to know. That is perfectly okay. Thank you for the honesty. Sear says 2 pi r. Kim says 2 pi r. Yeah. Nick says 8 pi. Okay. "15 years since Calculo, I forgot." Fair enough. Fair enough, Giggles. I just joined and I'm lost. No problem. We just got started. We just started a few moments ago, so you haven't missed much. So yeah. So our derivative, remember, I'm going to use power rule. And what the power rule say? It says take the exponent, move it out front, and multiply by my coefficient, and then subtract 1 from the exponent. So I have 2 times pi, so that's going to be 2 pi, times r to the 2 minus 1 power. Well, 2 minus 1 is 1, and a variable without an exponent is the same as that variable raised to the first power. But remember when I said that we're deriving with respect to time? So because we're deriving with respect to time, and r doesn't represent time, it represents our radius, I now need to add a dr dt. That's why we learned implicit differentiation. So that way we could do problems like this. Are you finding the derivative? We just did. OMG, wait, that's what I'm doing in Calc right now. Awesome! That's really cool. I'm glad you're finding it familiar, Giggles. Okay. Well, we're not going to do just circles tonight, so maybe there's going to be a problem that you do see. Thank you, Dex, for the follow. So now, mostly of functions and then recently of a boat and dock scenario. I think I'm saving the boat and dock for tomorrow. I have to check my list of problems, but I think we're doing that tomorrow. Because we're going to spend at least today and tomorrow on related rates. Hence why this live is called part 1. So now, I've taken the derivative on both the left and the right. Thank you, Giggles, for the follow. So what I'm going to do is now I plug in everything I have, everything I know, and solve for my want. Thank you, Annie, for the follow. So what I'm going to do is I'm going to plug in 1 everywhere I see dr dt. I'm going to plug in 4 everywhere I see r. So I have dA dt is equal to 2 pi times my radius, which is 4, and my change in radius over time, which is 1. Solving for this, I get 2 times pi is 2 pi. 2 pi times 4 is 8 pi. 8 pi times 1 is going to be 8 pi. And remember, we need to include our unit of measure. So, what was our unit of measure here? It was 1 foot, 4 feet. So my unit of measure will be feet But since I'm dealing with area, it's going to be square feet. And because I'm taking the area with respect to time, what's my time? My time unit is second. So my time unit here will also be second. So my answer is 8 pi feet squared per minute. Or per second. And that's it. Thank you, Elaine, for the follow. Thank you, Annie, for the follow. What's the highest level math I teach? Oh boy. So I've taught this. I've done Calc 3, I've done differential equations, I've done linear algebra. So I would say probably one of those three were the highest that I teach. Thank you, Yaz, for the follow. So any questions on this first problem? Someone asked for now do fractional Fourier transform. I think I'm going to stick with related rates tonight. So I'm going to assume that no one has a question, but if you do, hey Brandsy, how's it going? Wait, can you explain what dAdt is? Sure, so dAdt is just the change in area over time. So this is the derivative of A with respect to time. Like how drdt is the derivative of radius over time. Fourier transformed, isn't that used in music like the Overtone series? I'm not sure. If it is, that would actually be really cool. Is it derivative of time? It's a derivative with respect to time. Washer method next. Actually, it's funny that you mentioned that because it is already on my list of topic requests, which this was a topic request, so I'll go ahead and check that off. I need to clean up this list a little bit because there are some of these things that we've already done, so I need to get rid of them. Looks like electron configuration goal. Yeah, so this is my best drawing of ripples in a calm sea or a calm pond. Now, as I said at the beginning, I'm not a very good drawer, and to be honest with you, that's my best attempt at drawing a rock that's been dropped into a calm pond. Look, and as I said, you're gonna see me attempt to draw things, and I apologize in advance if they look terrible. Right. I'm good at the calc. The drawing not so much. Is this trig? Nope, it's calculus. This is calculus. Indeed. Did I ever teach algebra? I did. And actually, I still tutor a couple kids in algebra. I just saw that we had over 100 people in this live. Let's go! Second live in a row. Wow, what's next after related rates? So it really depends. For me, what I'm probably going to go over, sure. Can you explain why PEMDAS was taught wrong to me in middle and high school, but finally learned the correct way in college? That's a question. I'm not sure how you were taught it in college. So I can't really answer that without knowing. And that's my question too. What's the difference between algebra and calculus? Algebra is in calculus, but calculus is so basically calculus is like the culmination of everything that you learn in high school. Whereas algebra is the beginning of high school math. How did my teacher show me that? How did my teacher show me in school that one day? I'm not sure. I had this idea too. Props, bro, for going for it. I hope. Thank you, Tekkenic. Tenkinator. Can I do limit definition? I actually have that video on. I'm actually going to be posting that video here soon. Where is my card? Here it is. I'm going to be posting that in the next day or two here. But that, yes, I did do limit definition, and that's where you'll find it as soon as I post it. I see calculus as basically overpowered algebra and trig. It's just more efficient. It's more efficient than them. Let's substitute the R now. We could, but there's really no point in doing that. Calc is trying to teach you how to find formulas for lines and stuff. Almost. Really, so calculus answers two major questions. One, it answered a question of how do things change instantaneously? And two, how do I find the area under the curve? Yes, exactly. Calculus is indeed the study of change. So, let's go ahead and move on to question number 2. And I was over here cutting these problems a few minutes ago, and now I'm gonna hope and pray that my glue stick is able to get these problems onto the page without them flying away. Keep on talking. Okay. So yeah, like I said, my glue stick is, so I cut these problems out tonight, and I have 10 problems prepared. I'm gonna do 5 of them tonight, and I'm gonna make a part 2 for live tomorrow. And for those of you just joining us, first off, thank you for the 3K likes. But second, I'm gonna be going, because I have to get up early Saturday morning to drive 3 hours north. I'm going to be going live earlier on Friday. I'm going to be going live at about 6 o'clock p.m. Eastern. So, and I'll remind you all again tomorrow. Thank you, Luke, for sharing the live. So, a spherical snowball is melting. Its radius is decreasing at 0.2 centimeters per hour when the radius is 14 centimeters. How fast is the volume changing at that time? Okay, so let's go ahead and attempt to draw a snowball. Thank you, Princess, for the follow. So, I'm going to attempt to draw a snowball, or what I assume is a sphere. Let's have formulas. Yep, we'll get to those in a moment. But our first step, for me personally, it helps me to visualize the problem. Thank you, Taylor, for the follow. What's the volume for the formula of a sphere? It would be 4/3 pi r cubed. I think yeah, that's right. So, here, what do we know? What are we given? We're given that the snowball is melting and that its radius is decreasing at a rate of 0.2 centimeters per hour when the radius is 14 centimeters. So, what do we know? We know that dr dt because it's decreasing my rate is going to be negative 0.2 and my radius is going to be 14. All right, let's keep it PG here. Why does the radius at the time of measurement matter? Because the volume is going to change based on we're asking how fast is the volume changing at a specific point. So that's why it matters what the radius is. Sometimes we're going to be given the volume and we're going to be asked what the radius is. I was just learning about this in class today. Thank goodness I came across this live stream. Perfect timing, Chaos. So we know that the radius is 14 and that we're decreasing at 0.2 centimeters per hour. So our want is our volume changing. So dV dt. I'm going to symbolize that by putting a question mark there to show that that is our want. So now I need to go ahead and relate my radius to my volume. And actually, let me draw a radius or a radius. So dV dt then will be, we don't know. We have to find that out. So I need to relate my radius to my volume of a sphere. So I know that volume of a sphere is equal to 4/3 times pi r cubed. And believe it or not, I've been doing this for a while and I still mess this formula up from time to time. For a second, I thought this was the formula for a cone. But nope, I got it right, which is awesome. So now that I've related my volume to my radius, or rather my radius to my volume, it's time to take the derivative of both sides. So, on the left, remember that we are differentiating with respect to time. So the derivative of v is just going to be dv dt. And then, on the right, I want to take the derivative of 4/3 pi r cubed. What's the derivative of 4/3 pi r cubed? What is the derivative of 4/3 pi r cubed? Nicole says 4 pi r squared. This stuff proves there's a creator, among other things. This is just one thing. GGG says r squared. Almost. Kim says 4 pi r squared. So, Ty says 4 pi r. I assume that's a square. Beat says 4 pi r. Nope. Should be 4 times 4/3 times pi times r, right? Nope. Right, perfect. So, remember to do the power rule. I'm going to take my exponent, move it out front, multiply it. Just about to get there, Brandon. But that's exactly right. So, I'm going to take my exponent, move it out front, and multiply it by its 4/3. Well, 4/3 times 3, we say bye to the 3's. I'm left with 4 pi r to the 3 minus 1. 3 minus 1 is 2. But remember, we're not differentiating with respect to r. We're differentiating with respect to time. So I need to add a dr dt. Yeah, no problem. Just remember, everyone, because we're only allowed to differentiate with one variable at a time, and when we do related rates, we're always differentiating with respect to time. Thank you, 7381638 for the follow. Thank you, Osmili Cabrera and William for the follow. I apologize if I pronounced your name incorrectly. Got a test on Friday? Good luck! Good luck! I hope you do well. In fact, nope. I know you're going to do well. I believe in you. So now that I have everything I need, I can plug in my values and see what the answer is going to be. So remember my want is dv dt, so I'm going to leave that as is. Is equal to 4 pi times my r is 14 all squared times dr dt, which is negative 0.2. Now, 14 squared, what's that going to be? 196? So I have 14 times 14 is 196 times 4. So 196 times 4. That's going to be 4, 8, 7. So this is going to be 784 pi times negative 0.2. So negative 0.2 I can rewrite as negative 1/5. So this is going to be 784 times 1 over 1 times 1 over 5. That should be negative. That's going to give me negative 784 over 5. Which, if I do the conversion, what would that be? That's 15 add 30 is 6, so this would be what? 156 and 4/5? So 784 divided by 5. Yeah. So this is going to be, so dv dt is going to equal negative 156.8 pi. And what's my unit? My unit is centimeters per hour. So it's going to be cubic centimeters per hour. That's right, okay. That is absolutely right. This is going to be cubic centimeters per hour. Or, if you want to leave it like this, that will also work. Either way, these two things are the same exact thing. So that's it. This stuff always makes sense when someone else does it, but when I try it, my brain doesn't brain. Okay. Well, chaos. Let's try the next one. How do you do this? Why not multiply by pi? You can, but if you multiply If you we can approximate the value of pi, but if we do, we end up what's called with an approximate answer. Whereas if I just leave the pi there, it gives me what's called the exact answer. Please censor the double R word. What would that be? Just keep. Thank you, Beats, for sharing the live. Oh. Good one. Hey there, what's going on? No, that is funny. I didn't get it, but thank you for explaining it to me because that is funny. Cool. Yeah. So, do we have any questions on how we've solved this so far? I failed Calc 1 already. I'm on my redemption arc retaking the class. Absolutely. You know what, Chaos? That's great. I'm really glad that you're giving it another try. No, seriously, man, related rates was a nightmare when I was in Calc 1. Optimization is worse. I tend to agree with that, but I mean, related rates is something a lot of people struggle with. That's why I'm dedicating more than one live to it. Because I want to make sure that we get it, even if I spend multiple nights on it. I'm scared to take Calc 1. Aw, man. Don't be scared, Beats. Let me ask you a question, Beats. On a scale of 1 to 10, how well do you understand algebra and trigonometry? I'm taking Calc 1 right now. That's awesome. That's really cool, Vic. 5, I'd say, okay. Is that for both, or is that just for one or the other? Thank you, John, for the follow. I used to love math, and then I had to take calc, and it's been the death of my GPA. And I'll be honest with you, I took a math class that I struggled with as well, called differential equations. Thank you, Shamika, for the follow. And funny enough, I found Calc 1 harder than differential equations. That's fair. Algebra is easy. Trig was a bit hard. Calc is an utter nightmare. Both. I was just reviewing linear inequalities today. Okay, that's really cool. So if you're taking calculus, the biggest piece of advice that I have for you is that I want you to get good at your algebra and in your trig, because I can promise you you're going to need both to succeed in calculus. They say that, and those who have taken calculus 1 can agree with me, the hardest part of calculus isn't the calculus. The hardest part of calculus is the algebra. Because if you understand the algebra, there's only a little bit more complexity that calculus adds. I mean, that's my own opinion. No problem, Beats. I'm always happy to help. So, heck yeah, man. Wishing you the best on this. Seriously, this made Calc 1 hard. And I'll be honest with you, a lot of people. I struggled with related rates when I took AP Calculus. Thank you, Hassan, for the follow. So, this is how my college professor taught it. He told us, okay, first you want to draw out the scenario, then list what's given, list what you're given and what you want. The visual representation is what helps me understand what I'm trying to solve. Absolutely. And My high school teacher didn't tell us this, but my college professor showed us to draw. I got my first linear algebra exam tomorrow. Wish me luck. Good luck, Ben. You're gonna do great. I believe in you. I'm taking my thank you, Guppy, for the follow. I'm taking my first calculus class starting next week. I'm done for. I don't think so. I don't think so at all. In fact, that I think you're going to do better at calculus than you're giving yourself credit for. Thank you, Brody, for the follow. Is it one of those accelerated classes? Let's go ahead and turn the page, as my hand is shaking for some reason. Okay, I'm going to bed. When is your next live? So I go live every night at 11:30 p.m. Eastern. Although remember, Friday I'm going to be streaming earlier in the day. Remember, if you think you hit rock bottom, it can always be worse. Rocks break. Indeed. So, let's now do the next problem. Hey, Huya, how's it going? Okay, CO, then good night. Good night, Beats. Have a great rest of your night. I love your Thank you, Chaos. I try to be positive. Some days are harder than others, but positivity definitely helps. Man, I wish TikTok Calc Lives were a thing like 4 years ago. Calc 3 was where I drew a line. That's okay. Yeah, I'll be honest with you. I'm trying to make that's my goal. I want to make higher level math lives a thing. And I don't know of too many other people that do these higher level lives. Thank you, Pab, for the follow. Can you do acceleration, velocity, speed? I can definitely add that to the list. In fact, am I going to do that Saturday? I might do that Saturday. Friday or Saturday, one of the two. Because I do think it is important for us to know. So, actually, as you can see, I think I now need a third note card for these topic requests. Better, I need to clean it up a little bit. What is the topic for today? So today, we are doing related rates. And when is Calc 2 topic? So I plan on getting to Calculus 2. I'm aiming for beginning early October. I think I can get through the remainder of Calc 1 in probably the next 2.5 weeks or so. If you can start Calc 3 lives, that would be amazing. I'm taking it next semester and we'll need help. Yeah, definitely. Calc 3 is going to be a little while. But I think we'll be getting to Calc 3 before next semester. I think we can get through Calculus 2. I think I'll be starting Calculus 3 sometime around the beginning of winter. But again, those are timelines that I'm not sure about. So, let's do this next one. Oh, I don't remember if I answered this question, Carter, or not, but we're doing related rates. And we're going to be doing it in at least 2 parts. Tonight is part 1. This physics? No, this is calculus. A small balloon is released at a point 150 feet away from an observer who is on level ground. If the balloon goes straight up at a rate of 8 feet per second, How fast is the distance from the observer to the balloon increasing when the balloon is 50 feet high? Okay, I had a ruler here, and I seem to have misplaced it. But here we go. Here goes nothing. I'm going to attempt to draw this triangle. So I'm going to draw my little balloon. Let's draw a balloon. So here's our balloon. There's our balloon. And it's released from, let's say, this is the point where it's released. And we know that it's on level ground. So the ground, let's pretend for a moment that this is level ground. And here's our person. Here is our person. So, I'll draw that. So, if this is level ground and it's going straight up, this balloon will be perpendicular to the ground, which means that we have a right triangle. So, we know that the balloon, what are we given? We're given that the small balloon is released at a point 150 feet away from the observer. So this distance from this point to this observer is 150 feet. You just reminded me to do my physics homework. Awesome. So we know I'm gonna label my lines. I'm gonna label this side A. I'm gonna call this side B, and my hypotenuse I'm gonna call C. So what are we given? We're given that A is 150 feet. What do we also know? We also know that the balloon is going up at a rate of 8 feet per second. So dB dt is equal to 8. And I have pre-calculus test tomorrow, y'all. I'm cooked. I don't think so. We're given A, B, and the differential of a balloon's height. Right. B should be 50 feet too, right? Yep. So I was just about to get there. So we know that the balloon is 50 feet high. So we know that B is equal to 50. You have a pre-calc test tomorrow too? Okay. Good luck, Sarah, on your pre-calc test. I don't think you're cooked. And good luck, Jen, on your test. I believe in you both. Let's see if you both are right. So, my want is dc dt. Good luck. I hope you don't fail. I don't think they will. I think they're going to do great. I believe in them both. Seeing this as a senior engineering student brings tears to my eyes. Yeah, I imagine being when I first learned this like 15 years ago. Thank you, Trey, for the follow. Sending positive vibes? Absolutely, Chaos. So, someone said this should be DSDT, not DCDT. Why? Thank you, Dan, for the follow. Thank you, Trey, for the TikTok. I'm not quite sure what it is, but thank you. So, here's now. Thank you, Benjamin, for the follow. So now we need a formula to relate these three sides of a right triangle. Derive Pythagorean theorem. That's exactly right. So remember the Pythagorean theorem. It's a squared plus b squared equals c squared. Now, before I take the derivative, I want to know what c is. Why? Because I want to know the distance between these two, so that way it can help us find our value of how c is changing. So here, I'm just going to use the Pythagorean theorem. So 150 squared plus 50 squared equals c squared. 150 squared is the same thing as 15 squared with 2 zeros. So 15 squared is going to be 225. Add 2 zeros, I get 22,500. And 50 squared is going to be the same thing as 5 squared with 2 zeros. So that's going to be 2,500. And that's going to equal c squared. So now 22,500 plus 2,500. That's going to give me what? That's going to give me 25,000. Thank you, Griffin, for the follow. And now, if I take the square root of both sides, what's that going to give me? Thank you, Frog, for the follow. You're killing it, man. Love it. Thank you, Griffin. I'm really happy to hear that. So, if I plug in the square root of 25,000, I get approximately 158. What are we doing today? We are doing related rates. So I'm going to go ahead and leave it. Actually, let's do this. I'm going to leave it as the square root of 25,000. 50 root 10? Yep. I could do that as well. Why? Because 50 times 50 is 2,500. And actually, that might be cleaner. So let's do that. Let's let c equals 50 times the square root of 10. And now I have everything I need to figure out what the value of dc dt is. So now I need to take the derivative of the Pythagorean theorem. So remember, we're deriving with respect to time. So what is the derivative of a squared with respect to time? What is the derivative? Jacob says 2a dA dt. Crazy Snail says dA dt. Okay, guys says 1, it doesn't change. Thank you, Heidi, for the follow. So yeah, doesn't change. Yeah, let's watch the language a little bit, please. So yeah, I do agree with you. I do agree that it's not going to change, so its derivative is going to be 0. But using the power rule, I'm going to say that this is 2a dA dt. And we're going to plug in 0 for dA dt here in a moment. All right, 100 people in this live. Let's go. And then, what's the derivative of b squared? That's right, Griffin. It's going to be 2b times dB dt. And then, Jacob is the GOAT. He is indeed. And then the derivative of c squared is just going to be 2c times dc dt. So now I'm going to plug in my values to solve for dc/dt. But remember, dA/dt, we don't know it. We haven't found the derivative of a with respect to t. But we know that this distance is constant. So what's the derivative of a constant? That's right, Guppy. It's going to be 0. So can't we just plug in for a? Yep. But what's going to happen is we know that since a doesn't change, dA/dt is 0. So this is just going to be 0. But just for the point of exercise, I'm going to plug in everything I know here. So I have 2 times 150, because that's a, times dA/dt, which is 0. This should be a plus sign, not an equal sign. Plus 2 times b, which is 50, times dB/dt, which is 8. And that's going to equal 2 times c, which is 50 root 10, times dc/dt. And as we saw earlier, anything times 0 is 0, so this is going to go away. So I'm left with 2 times 50. That's going to be 100. 100 times 8 is 800. Equals 2 times 50 root 10, so that's going to be 100 root 10 dc/dt. I'm not going to lie, in class I didn't pay attention. I just plug in the numbers where they seem right. Okay. Fair enough. I'm not going to... I would pay attention, but... So now, what should I do? What's my final step going to be? That's right, Donovan. It's going to be divide both sides by 100 root 10. And I'm left with 8 over root 10 equals dc/dt. And don't forget that I need to add my unit of measure. What's my unit? It's going to be feet per second. So it's going to be dc/dt equals 8 over root 10 feet per second. And that's it. Thank you, Crazy Snail, for the follow. D cancels with D and you just get Z over T. Nope, not in this case. Thank you, Emmanuel, and thank you, Gibby Martinez, for the follows. And here's the puzzle piece. Gotta love that puzzle piece, folks. Can you simplify it more or no? So in calculus, normally in math, your algebra and your pre-calc teacher would tell you to rationalize the denominator. But in calculus, we actually don't have to do that. Thank you, Equation, for the follow. So in calculus, we actually can leave the answer as such. Thank you so much for this. I sincerely appreciate it. You're welcome, Chaos. Calculus rocks. Indeed it does. Jumped in late. Could you give context to the answer? Sure. So we were trying to figure out how fast the distance between this person and this balloon is changing at a particular point. Why not? Are you asking me why we don't have to rationalize the denominator, or Thank you, Reza, for the heart me. Okay, so the reason why we don't have to rationalize the denominator is because it. That is actually a really good question. That's actually a really good question. Yeah, I guess it does depend on the teacher. I've always taught my students that you don't have to rationalize in calculus. Hey, Santiago, how's it going? Can you do a question like this, but it's with a cone? I do have a cone question prepared, but tonight's not the only night I'm going to be doing related rates. I'm going to be doing related rates as well tomorrow, and I actually do have a cone. I have 2 cone questions for tomorrow. Thank you, Caster, for the follow. Got it. I'm on my third week of pre-cal, just trying to hang in there. Fair enough. Thank you, Nikki, for the follow. I will be here for it tomorrow. Awesome. In fact, I'll show you that I have those 2 cone questions. They are right here. But I'm going to save those for tomorrow because I haven't cut them out yet. That and I only have 5 problems prepped for tonight. Thank you, Chris, for the follow. Cool. Unless finding the limit is not necessary to rationalize. Right. Thank you, DM, for the follow. And thank you, Joe Boy, for the follow. Leave the answer in the same form it was in the question. For example, if the question had decimals, your answer should be in decimals. Well, remember, I can write a decimal as I can write any decimal as a fraction. Well, except for like pi and e and stuff. But I find that I find personally that fractions are easier to work with. If you want to convert it back to decimals, by all means, go for it. If the question asks you for the answer in decimals, go for it. But personally, I find that it's easier to deal with fractions. Keep the square root, just get the radical out of the denominator. Like I said, in calculus, we actually don't have to, and I choose not to. But if you want to rationalize this, then by all means. It ends up being what? It ends up being 8 root 10 over 10, which is 4 root 10 over 5. Thank you, Francisco, for the disco. Thank you for the disco. I don't know what that's called. All I see is disco, so that's what I'm going to call it. I'm crying. My optical physics would never. Okay, and like I said, if you want to rationalize that, by all means. All right. So now let's turn the page over and do question 4. Do you do stat problems? I do. I'm trying to find a good time to do stats. In fact, my last student just settled on his new schedule, so I'm gonna be having a second live here soon. I just need to figure out. I need to look at the analytics and take a look at what time is best to do a second live. Life is just a function when you live in a world of math. Thank you, Rezal, for the follow, and I apologize if I pronounced your name incorrectly. So let's see who's gonna win, me or the glue stick. Apparently, I did this time. Cool. Square root is a type of radical. Not all radicals are square roots. Right. That's absolutely right. can you help me with a math problem I'm working on? Sure, if you want to send it to, if you want to DM it to me, feel free. Blue stick always wins. Absolutely. Short term, I might win once in a while, but long term, we all know that the real victor is the glue stick. If you're not able to type out the problem, feel free to take a photo of it. I think I can receive photos on TikTok. I'm pretty sure I can. I don't see why I can't. Anyway, the sides of a square are increasing at a rate of 3 centimeters per second. When the sides are 5 centimeters long, at what rate is the area increasing? So here we go. Time for me to try and draw a square. Or I should probably draw 2 squares to show that we're growing. So here's my first square. And again, I apologize for the horrible drawing, because I'm not very good at drawing. And here's my second square. I'm going to draw that to symbolize it's growing. Well, dsdt is 3, right? S is 5, A is S squared, and A is currently 25. Right, so, and my want is my dA dt. So let's take a look. So the sides of a square are increasing at a rate of 3 centimeters per second. So sure, we'll use ds dt to represent sides, is 3. And the sides, which is S, will be 5. And my want is dA dt. So now that I have what I'm given, I need to go ahead and find the how fast. So I need to relate the sides to my area. Luckily, this is a square, so the area of any rectangle is base times height. But with a square, the base and the height are equal, so it's going to be s squared. Limit as t approaches 1 of... Okay, let me write this down. Limit t approaches 1 of 1 over t plus 3 minus 1/4 over t minus 1. Is that right? Okay. I'm gonna save this for later, but like I said, feel free to just DM me, and I'll show you how to solve that. So here, now that I have a relation between the sides and my area, I now need to find the derivative of both sides. The derivative of A is going to be dA dt, because remember, we're deriving with respect to time. What will be the derivative of s squared with respect to time? All I want is the derivative of this. I'm not looking for plugging in values quite yet. All I want to know is what the derivative of this s squared is. OK says 2s ds dt. Luke says 2s. Almost, Luke, you're missing something. Riri says 2s. Almost, Riri, you're missing something. Nope, we're not taking the antiderivative. Almost, Luke, but it's not r. Gabe says 2s dsd times ds dt. Yeah. K says 2S DS. Almost K. You're almost there. You're just missing something. Is this needed every time, and why is it structured this way? This is how I learned related rates. I'm showing you how I think it's how I think I assume my multiplication was implied. Did you No, it is. I understood that. Okay. Thank you, Gabe, for the follow. So here it's going to be 2S ds dt. Thank you, Samurai, for the follow. All right, back to the question from your dad. Is this needed every time, and why is it structured this way? So if some people, I personally like to do problems this way because it helps me to understand. Okay, I've broken down the problem as much as I can. I'm looking at what's going on, and so it's helping me to solve. It's helping me to solve the problem. Thank you, Guitar Candy, for the follow. So I do this for every related rate problem. So now I'm ready to plug in. So I can plug in my S and I can plug in my DSDT. So my question to you all is, what would DADT be? I thought it was DYDX. So here I just chose the variable to be S. But remember, when we do related rates, we're always differentiating with respect to time. Or is it based on what we're working on? So it really depends. So implicit differentiation, we're deriving with respect to x, and when we do related rates, we're still doing this implicit differentiation, but our variable is going to be we're deriving with time, with respect to time. Ashley says 30. DADT is what we're looking for, so that's unchanged. S is 5, DSDT is 3. Right. So when I do the multiplication out, what do I get? Adrian says, sir, I need statistics help. Okay. Feel free to DM me and simplify to 30. I'm in differential equations now and I can't even remember what I'm looking at. So this is related rates. So it's change of position or change of position over change in time. Right? Yep. No static help. I'm not quite sure what static help is. So yeah. So 2 times 5 is 10. And 5 times 3 is 30. Stats. That's what I thought as well, but apparently Adrian's saying no, it's not. So DADT is 30, but remember we need to include our unit of measurement and our unit of time. So my unit of measurement is centimeters, but remember we're dealing with area, so it says square centimeters. And what's my time unit? My time unit is seconds. So it's 30 square centimeters per second. Feet squared per second? No, not in this case, because we're given that it's centimeters per second. If it were FT per second, then yes, that's absolutely right. Right, yes, that's correct. Which is why we have to be careful and understand what our unit is. And our unit is, if not all the time, a lot of the time going to be given. Where's the 2 come from? I assume you're talking about here? Cool. Yeah, so we took the derivative of s squared. So that required this thing called power rule. So power rule says that if I have a variable raised to a power, its derivative is going to equal take the exponent, move it out front, and multiply by whatever coefficient's in front, and then I subtract 1 from the exponent. So the 2 came from me taking this exponent and moving it down. How forces act on a physical system that is at rest or at equilibrium. It has been what is it, 15 years since I've done physics. So I would not, unfortunately, I would not even begin to know how to help you on that. It's physics and calc 2 together. Oh, are you talking about like I think I know what you're talking about. I'd have to take a look at it, but I do think I know what you're talking about now. Yeah, no problem, Kelvin. Always happy to help. Yeah. So any questions on this one? It's actually it's actually good that I only prepared 5 problems because we're already an hour 21 into this. So let's go ahead and do final problem. Naturally, I'll write the final problem up here. So thank you, Z, for the follow. 67 viewers. That's actually real. I'll be honest with you. I spent a month with only like 8 viewers in here. So anytime I've only hit 100 plus viewers at any one time on 2 lives, and actually those were my last 2 lives. So I'm hoping that's a trend. So yeah, so there are 70 us of us in here. Let's see if we can't get to 5. Let's do a quick mad tap to 6K likes before the final problem. I think you all can do it. I know you can. So yeah. So while you're doing that, let me see if I can find what you're talking about, Adrian. I think I know what you're talking about. I just have to verify what you're meaning. Statics, a branch of engineering mechanics. I think you need to text me so they can go through. Let me open up my TikTok quickly and just see. Hmm. Yeah, so as far as I know, statics is a completely different class. Are you studying to become a mechanical engineer? No, civil engineer. Okay, that's cool. I've actually never taken statics before, so I would have to take a look at the materials, see if I could But there's a lot of mechanical engineering in my class. Okay, yeah. I'm ready, coach. Let me at this question. Almost, James. We're doing a mad tap to 6K first, and then we're going to get to the question. And we're only 500 likes away, so let's see if we can't get to 6K. But I appreciate the enthusiasm, James. I see that enthusiasm over there. Almost there. 100 to go. And there we go. All right. I probably should have glued this question. I probably should have put the glue on this question before while you were doing that. But I'm going to do that right now. Because it would take me, if I attempted to write these problems down on this paper, it would take a while. So here we go. All right. Two roads cross at right angles. An observer stands on the road 50 meters south of the intersection and watches an eastbound car traveling at 45 meters per second. At how many meters per second is the car moving away from the observer 5 seconds after it passes through the intersection? All right. So first step is I'm going to need to draw this out. So if there's one thing I'm bad at, I know I've said this a lot tonight, but if there's one thing I'm bad at, it's drawing. So here goes nothing. So here is my intersection. And I'm going to assume there's a stop sign. I'm going to say there's one. The stop sign is normally on the right side of a road, so there's going to be a stop sign here. There's going to be a stop sign here. There's going to be a stop sign here. And I don't know if these are going to be, if this is a intersection that has stop signs or a stoplight. We're going to assume that there are stop signs, and we're also going to assume that we're on a dotted line road. So now here's my person. So here's my person over here on the side of the road, not on the road. Here's my person. And then here's my car. It's driving eastbound, so it's going to go this way. So here we go. Here goes nothing. So here's my car. And there are the wheels. Here's the dash and the driver. Again, not whore. So, what do we know? We know. Yes. So here, we want to find the relationship between. So intersections meet perpendicularly, and I'm going to draw the distance between the car and the person as that right there. And actually, let me draw a person a little bit there. There we go. There's nothing in the problem specifying that the eastbound car has to change its velocity. Right. Not necessarily. Well, we know that the car's going that fast, but we want to know how fast the distance between the car and the person is changing. So, I'm going to call my vehicle, what should I call it? This is calculus. So I'm going to call it, what should I call it? Let's call it V for car. Or V for vehicle. And then we'll call this, let's call it S for south. We'll call this C. If you want to use A, B, and C, then go for it. So here, the observer is standing 50 feet away from the intersection. 50 feet south, or 50 meters south, is the distance between the intersection and my person going to change? No, it's not going to change. So ds dt is going to be 0. My S value is going to be 50. And now we know that the car is traveling at 45 meters per second. So dv dt is going to be 45. And someone said earlier, but we know that that in order to figure out how many meters the car is away from the intersection, we take our rate and multiply it by time, because distance equals rate times time. So a vehicle's location is 45 times 5. So that would be what? 45 times 5 would be 225. So V is 225. And my want is dc dt. Wait, why is it 225? That's a good question. So it's 225 because we need to figure out the distance. We need to figure out the distance of V. So in order to do that, we know that the car is traveling at 45 meters per second, and they've been traveling for 5 seconds. So distance equals rate times time. So my rate is 45 meters per second, and my time is 5 seconds. So 45 meters per second times 5 seconds. Seconds cancel, and that gives me 225 meters. Do you really need dc dt here to vote? Yep, that's what I'm solving for. We're solving for the distance from. We're solving how fast the distance is changing from the person over here to the car. Seems like it's just Pythagoras on 225 and 50. So that's going to give us our C value. So you're absolutely right, stat. I do need to do Pythagorean theorem here to figure out my C. So I have 225 squared plus 50 squared is equal to C squared. If I solve for that, what is C squared going to equal? So what would C squared equal? I'll give you a moment to figure that out. So the reason, does that answer your question, stat? Third year math major here. What's the problem statement? So we're solving for we're trying to figure out how many meters per second is the car moving away from the observer 5 seconds after it passes through the intersection. So we're trying to find the rate at how fast the car is moving away from the person. Hence dc dt. Rate stat is going to be 53,125. So if I took the square root of that, I would get about 230.4. So instead, what I'm going to do is I'm going to go ahead and just call it C equals the square root of 53,125. Now, is there any perfect square that goes into 53,125? Or let me ask this another way. Is there a way that I can simplify that? I don't have a calculator handy without switching out of TikTok. That's fine. I'm going to use my phone as a calculator. Alright? So I'm going to look up the factors because so I can write this as 25 times the root of 85 yeah. So this is going to be my C value. So from here, what I'm going to do is now I'm ready to take my derivative. So I have s squared plus v squared equals c squared. Again, I am aware that ds dt is going to equal 0, so the derivative of this is going to end up being 0, but without plugging anything in, what would be the derivative of this term on the left side of this on this side of the equal sign without plugging anything in? Well, not quite. We know that's how fast the car is moving, but that doesn't necessarily mean that's how fast it's moving away from this person. Yeah. So here, for the sake of exercise, s squared is going to be 2s times ds dt plus 2v dv dt. And on the right side, it's just going to be 2c dc dt. From here, I can plug in all my values. So I have 2 times 50 Why won't this pen work? times 0 plus 2 times my V, which is 225, times dV dt, which is 45. Why is that? What? Why my pen won't work? I'm not sure. I'm trying to figure that out myself, to be honest with you. Can you solve symbolically before plugging in values? Yeah, absolutely you can. If you want to solve for dc dt and then plug in the values, go for it. So that's going to equal 2 times 25 root 85 times dc dt. I mean, you'll have to forgive me, I'm only half paying attention, changing my batteries. Okay, fair enough. You're the best. Can't stop watching. Thank you, Vicky. I'm really happy to hear that. I'm going to switch pens. I mean, how did you get that equation? Are you talking about this one? Okay, so I just took the derivative of this top equation using power rule. So from here, what am I left with? That's 0, so I'm left with 2 times 25, 225 times 45. 2 times 45 is 90. Now all my pens aren't working for some reason. So I have 225 times 90 gives me 20,250. Okay, third pen and still not working. I wonder why that is. Let me try moving this down on a flatter surface. So let me put that there. Move those for a moment and bring my camera down here. Now let's see if it works. So I have, what was my answer? It was 20,250. So, still not. There we go. 20,250 is equal to 2 times 25 times root 85. So that's going to be 2 times 25 is 50. 50 times the square root of 85 times dc dt. And then finally, I'm going to divide both sides by 50. I apologize that my pen seems to have stopped working. Root 85. And so, dc dt is equal to 20,250 divided by 50, which is 405, over the square root of 85. And all I need now is my units of measure and unit of time. So my unit of measure is meters, and my unit of time is seconds. So my answer is that. Any questions on this problem? So with that is the last problem of the night. But I want to stream for 2 hours every night. So at this point, let's go ahead. I'm going to go ahead and spend the last 15 minutes or so just talking. So, how is everyone's Wednesday going? Or should I say Thursday, because it's now Thursday morning out over here on the East Coast. Naturally, let me put that down here so that way you have something other than my desk to look at. Bad, I have a Calc BC quiz tomorrow. Okay. What's your quiz on? On 1D motion related rates hyperbolic trig. Okay. 1D. Oh, right. No, I understand now. I don't like related rates. Like, why are we doing physics and math? So, related rates. So, a lot of people ask about the application of calculus in real life. That's what related rates are. There's also this thing you're going to learn about later on called optimization. Um, and I'll be honest with you, a lot of people really struggle with related rates because, and this is my own personal opinion and my own observation. I find that a lot of people struggle to actually break down the problem into something I'm not going to say useful, but um, into a way where we can actually manipulate it and solve and make an equation out of it. S and V are functions, so that's why power rule we have to multiply them by the derivative as well. Yes, I agree. For me, it's hard to find what equations relates the two variables. That's fair. That's absolutely fair, Amara. And a lot of people do. I when I first did calculus, when I took it in high school, related rates was one of those topics that got me upset because it's like how do I know which one is which? And the thing is, you already know the formulas. All you have to do is just recall them. Like, you know the Pythagorean theorem. If I were to ask you the Pythagorean theorem, you'd be able to tell me, I think. You'd tell me a squared plus b squared equals c squared. But the question is, how do we know to use that, right? And that's the biggest, and I think that's the most complex part um of these types of problems is knowing, okay, how can I relate the two questions? And that's why I take the time to draw these, because I found personally that for me, when I draw the question out, it helps me visualize the problem better, and so it helps me say, okay, here's my relation, here's what I'm looking for. This was great content to scroll into at 1 a.m. Thanks. You're welcome. You're most certainly welcome, Amara. And like that, what do you recommend for practice problems on Calc BC? Khan Academy ones aren't challenging enough. Okay, here's my honest opinion of Khan Academy. I think if you're just learning a topic, it's great. Thank you, Stat, for the follow. But I really think that where Khan Academy falls short is or like that. This is my own personal experience, so it's just me. But I think the one thing about Khan Academy that I wish they would do is I wish they used more than the same 8 problems for a particular section. Because eventually, if you do Khan Academy enough, you're gonna see problems again and again. So you'll know, okay, here's how I solve those problems, but I'm still lost on how to actually solve other problems. And normally I'd recommend IXL, but IXL doesn't go up to Cal AB. I mean Cal BC. So it's really tough to recommend something. Personally, if I were you, I would recommend getting a book. I have a couple here that I use. I have I actually just got this book on Monday because I had to update my stuff anyway. My BC book is over here. So I use. Oh no, this isn't it. Is it in the other room? Yeah, it probably is. Anyway, so here is the book that I'm using. I just got it the other day. It's the Princeton's Reviews AP Calculus prep book. So, um, I've had this now for a couple years, and it gives you everything that you'll need. They do have a BC version, and I have a copy of BC in the other room. But that's one thing I would recommend. Um, and they'll give you they have the thing I like about this is that they have practice tests on the back, and it's not just like, okay, here are some problems from the past three response questions. No, they have full length tests, and actually your practice tests are going to be in the back of the book. So they have stuff like they have the full multiple choice test. This is just one practice test out of like 8 that's in here, which is really awesome. They also give you the answers of the questions. They also give you explanations for that. You're welcome, Omar. I'm really happy to help. To help America, you should be teaching AI programming. Nobody does calculus. But that's the thing. People do calculus. Thank you, Woody, for the follow. There are a ton of There are a ton of places where calculus is used. Do I think AI programming is important? Absolutely. I'm not good at it, so I don't teach it just because I don't know a whole lot about it, and I want to show you stuff that I know, not something that I don't know. But yeah, so we have about 6.5 minutes left on this live. We've been I've been on live for almost 2 hours. That's cool. So yeah, so tomorrow I'm doing part two of related rates. Thank you, Tech Whale, for the follow. What math is this? This is calculus, specifically Calc 1. I have to follow a few who do math on TikTok live. Yeah, and that's the thing. This is this is this is something that I want to do. I want to bring math everywhere I go. I'm in Calc 3 right now. It's tough. Absolutely. Transitioning from um single variable to multivariable, especially when we have to deal with multiple dimensions. That's always fun. Thank you for the follow. I wish I show how calc related to LLMs. Thank you, Isaiah, for the follow. Do you know anyone that teaches physics on TikTok that you could recommend? I actually don't, but the thing is, I wish I wish I did. And if I do, I'll let you know. Thank you, Isaiah, for the follow. Alright, next question. What are LLMs? No, I'm gonna sound probably stupid for asking that, but I don't know what that is, so I had to look that up. Large language models. I had to look that up. That's actually really sad. So, yeah, I could probably do that. I'd have to know a little bit. I'd have to look it up a little. I'd have to do a little bit of research, but yeah, Tech, I could probably do that. Where were you 10 years ago when I failed calculus? Where was I 10 years ago? I just graduated college like 4 months before. So I was probably in my first teaching job. But yeah, I first took calculus when I was a senior in high school 15 years ago. Oh wow, it's been 15 years. It's been almost 15 years since I graduated high school. That's a sobering thought. Great. So yeah, no, I enjoy teaching calc. I personally think this is my favorite thing to teach. LMN is an angle where M is a vertex. Yep, that's right. It's also what is it? Lifetime Movie Network. So I do. So do I do calc problems for fun? Uh, Depends on the situation. Sometimes I do them to make sure our problems are going to be able to be done for lives. But sometimes, yeah, I'll brush up a little bit on calc, especially stuff that I haven't seen in a while. Yeah, Lifetime Movie Network. That's LMN. Yeah. Um. So yeah, almost all of machine learning is effectively optimization problems, error minimization. Yeah, that's right. Is this a whiteboard or your laptop? Neither. This is a sketchbook. This is a sketchbook I picked up at Staples. I used to do my work. Where is it? I used to do my work on these sketch pads, but what ended up happening was when I flipped um up my paper over, I would punch holes into this paper. So that's why I don't use these anymore. How are you getting your camera to point downwards? That's a good question. And the answer is I'm using a document camera. I have a document camera plugged into my computer. Now, one thing I do want to do eventually is I've seen people have half the screen focused on what they're working on and half the screen on their face. I'm still trying to figure out how to get that to work. What type of questions am I doing? So tonight we did related rates, and we're going to continue on them tomorrow. Yeah, so I like I said, I got this document camera for like $50 on Amazon. Document camera just took me back to elementary school. Yeah, you need OBS Studio for that. Okay, that that's actually good to know. Um, it's been I might hmm yeah, that's good to know, Griffin. I'll have to take a look at that, see if I can make it work. Plus, the thing is, I have really bad lighting in this room. In fact, I only have one lamp right above my head. So what ends up happening is that if I turn this light on, it's going to cause a shadow on the paper, which is fine. It gets annoying to see from time to time, but it's fine. So that's why my document camera has lights in it, so that way you can see what I'm working on and not the shadow. Even though I can see the shadow underneath the pen. It's free, you'll just need a webcam. Duly noted. So yeah, so we have hit 2 hours, which is awesome. Thank you everyone for joining me tonight. And before I go, I do have a couple things that I do need to mention before I get out of here. So first, let's start by talking about where all of my lives are going to end up going. So I'm in the process currently of downloading all my lives, and as soon as I do, they will be uploaded here. So you'll be able to find them on this at this channel. So if you go here and do these 5 things, that would be awesome. Apparently I'm really hungry, or so my stomach says, even though I just ate a couple hours ago. Anyway, so now the other thing I want to show you is that I am an online math tutor. So, do I know anything about mechanical vibrations? I do not, I'm afraid. Yeah, I'm always in the process of finding new TikTok channels that I like, and if I find any, I will definitely recommend them. So here is a list of every subject that I tutor. So I offer group tutoring and I offer one-on-one tutoring. So for group tutoring, I offer tutoring to groups of 3 to 10 students, all taking the same class at the same time. So it doesn't have to be you don't have to be taking it at the same school or with the same teacher. So if you and 3 of your friends are, say, taking linear algebra and you're all taking it at the same exact time, then we can have group tutoring. I also offer one-on-one tutoring for any of these subjects. So if you're interested in either, please feel free to DM me and we'll set up a free consultation. Also, here are the things that I am currently working on. So I'm still working on getting these flashcards done. I'm trying to do them in a way that's not just like the generic flashcards. I want to try and make them have a little bit of style. And also, I'm working on a set of calculus rules, but not just a set of calculus rules, but a list of tips and tricks on when to use those rules. And I'm also working on a notebook. I'm in the early stages of getting my format down, but as soon as I make some stuff, I will make sure they are available for you all on my TikTok shop. And finally, there are a couple other people here on TikTok that I highly recommend that you follow. So, the first is ACG Math Tutoring. So Audrey was the one who actually convinced me to join TikTok. So if it weren't for ACG Math Tutoring, thank you, Caden, for the follow. So if it weren't for ACG Math Tutoring, I wouldn't be here right now. So she is someone who is gonna get you ready for your ASVAB, your Accuplacer, your GED, your TEAS test, and just if you want a refresher on your Algebra 1, 2, or Geometry, she's really awesome. And then the other math TikTok channel that I recommend you follow is Learning with Lynette. In fact, I think that she is still live right now. So, and if she is, which she is not, she must have just ended it. Anyway, so she is good. She's great with the abacus. She's really entertaining. It's really fun to watch her lives. And so I would highly recommend that you follow her as well. Are you good with physics? It has been a long time since I've taken physics. I haven't taken physics since I was in high school, so it's been a while. But if I relearned it, I could probably recall a lot of it. But thank you, Yesena, for the follow. But yeah, I haven't taken physics in a while. But yeah, so with that, just as a reminder, I go live every night at 11:30 p.m. Eastern time. This Friday though, remember, I'm going to be going live not 11 at 11:30 p.m. Eastern, but 6 p.m. Eastern. So that's going to be a little bit of a different time. But every other night I'll be live at 11:30 p.m. Eastern. So with that, I hope you all had fun learning about related rates tonight. And like I said, we're going to be continuing this tomorrow. So um, please join me then. And with that, I will see you all tomorrow, or should I say today, because like I said, for me today, I'm on the East Coast. So it's Thursday now. But yeah, I will see you all at 11:30 p.m. Eastern on Thursday for some more related rates. Bye, everyone. It says I'm just 10 minutes away from my next reward. Should I stay on another 10 minutes? Yeah, let's stay on another 10 minutes. I guess, as I said goodbye, I just found out, hey, you're 10 minutes away from your next reward. So I'm going to stay on for another 10 minutes or so. So yeah. So what do you want to talk about? What do we want to talk about for the next 10 minutes? Hopefully everyone's had a great Wednesday night if it's not over yet, but even if it is, why is that showing up? Hmm. Anyway, so um so anyone who has been in here before knows that I play fantasy football, and so I need to ask you all a question. If um so I got a trade offer, or actually before that, so I am I just got my first one in one league, and I'm 2-0 in the other league. In the league that I'm 2-0 in, I'm defending my fantasy crown from last year. And I mean, I think I have a pretty good team. But I want to know who. I want to know. I would ask you who you think is going to win tomorrow between the Bills and the Dolphins, but that game's going to probably be over by halftime. But yeah, that's better. Up. There you go. I don't know why he did that. So yeah. So I am getting close to 2K followers on here. So I just want to say thank you all for helping me get to where I am right now. And yeah. Yeah. All right. I think I'm going to head out now. So, yeah. Have a great rest of your night, everyone. And I will see you all tomorrow at 11:30. Bye, everyone.